Assalamualaikum warahmatullahi wabarakatuh. We are from group B3. We are going to present to you about heat engines. Next. So, my name is Awisha Satina, the member of the group B3. Azrin, Wan Humai and Ahmed Firdaus as well, also group 3. Next. Okay, for the background of company. Next. AKI Sdn Bhd was established on 5 March 2020 with a clear target to be recognized as a company that manufactures high quality engine and always be the first choice. We're struggling a lot to put our company on top. After struggling for over 2 decades, we have experience and confidence to acquire that title. Our company has expanded its engine range and produced thousands of different engines, including heat engines and heat pumps. Next. As Madam know, the device that we choose is heat engines. So what is the heat engine? Heat engine is a mechanism such as an internal combustion engine for converting heat energy into mechanical. So what is heat engine does? Heat engine move energy from hot place to a cool place and divert some of that energy into mechanical energy. So there are two types of heat engine, internal combustion engine and also external combustion engine. So for the example of heat engine is gasoline and diesel engine, jet engines and turbine engines. Next. So this is the example of diagram with labeling heat engine. Next. And these 4 pictures are also the example of heat engines. So I will pass to Amir Firdaus to continue talking about flow process.
Okay, for the flow process of heat engines, next. So heat engine is one of the closed system, which is its work in cycle fashion, and usually it use pistons. So the piston will cycle up and down and create high pressure steam when moving up and escape when moving down. Heat created by burning the fuel to make higher temperature steam, which is QH. And the remaining heat that exhausts to the environment at a lower temperature is QL. So the net heat energy absorbed can define as Q equals to QH minus QL. And the internal energy will remain the same. So we can define as U equals to 0. So the W net can define as equals to W out minus W in, which is the theta W out amount of work delivered by system as it expands in heat energy, and theta W in amount of work required to compress the heat to steam temperature. So I'll pass to the next presenter, which is Humad.
Hello, I'm Wan Humai. I will continue with circular thermodynamic and heat engine. First, I will explain about circular thermodynamic. Heat flow naturally from a hot object to a cold object and cannot flow from a cool object to a hot object without doing work on the system. Heat energy cannot be completely transformed into mechanical work with 100% of efficient. All natural systems tend toward a higher level of disorder, or we call entropy. The only way to decrease the entropy of a system is to do work on it. Heat transfer occurs spontaneously in the reverse direction. In thermodynamics, a heat engine is a system that performs the conversion of heat or thermal energy to mechanical work. Heat transfer from the object or hot reservoir is denoted as QH, while heat transfer into a cold object or cold reservoir is QC, and the work done by engine is W. The temperature of the temperature of the hot and cold reservoir are TH and TC, respectively. To be easier to understand, for example, diagram A show heat transfer occurs spontaneously from a hot object to a cold one, consistent with the second law of thermodynamics. And then diagram B, a heat engine represented here by a circle, use part of the heat transfer to do work. The heat and cold object are colored by hot and cold reservoir. QH is the heat transfer out of the hot reservoir. W is work output, and QC is the heat transfer into the cold reservoir. And that's all from me. I will pass to the next representer.
Nice. Okay, so this is a steam power plant. It is one of cyclic devices for heat engine. So the process starts with water from the pump that generated to the boiler. Then water in the boiler will receive the heat from the a high temperature sources, like in the diagram show QH is flowing into the boiler. Um, High temperature sources such as a furnace. The water in the boiler will turn to the superheated steam, and the superheated steam will flow into the turbine, and it will rotate the turbine blade so it produce work out. That work is to generate electricity. Then it will turn from high pressure steam to the low pressure steam. So the steam will convert into liquid in condenser. Water from seawater used to cool the low pressure steam from turbine, because heat from the steam will rejected to the low temperature sink. The liquid will flow into the pump, and it will continue to complete the cycle. So that is all from me. Thank you. That's the end of our presentation. Thank you so much.